All right, as you guys are kind of wrapping that up, today we'll finish up 3.5. It shouldn't take real long. So I put together a Kahoot. That's right, a Kahoot. The practice derivative rules, some of the trig stuff. Okay. So a couple minutes to kind of study those. Just a little way to help you memorize the trig derivative rules. Got to know those quickly. All right. So we'll do that. Tomorrow I have an AP derivative practice that I put together on AP Classroom. It says it's a quiz on there, but we're going to do it in class. On the agenda, yeah, I changed it today. It just said practice derivatives. I wasn't sure if we're going to do a worksheet or what. It's kind of a mixture between multiple choice and extended response. And then Friday we'll start the chain rule. It's going to be a big, big, big topic for us. All right, so fingers crossed. Did you use the correct derivative rule here? You use the product rule. First times the derivative of the second. What's the derivative of cosine of x? Sine of x. Plus the second times the derivative of the first is just 1. Why is that a product rule? First of all, how many of you use the product rule there? Ooh, just 2. Uh-oh. Okay, so those of you who did not use it, what did you think? What did you think it was? It's okay, speak to me, own it. Not everybody's right all the time.
I just did negative sine x.
So just blew right through the x. Just said,
Yeah.
I see you, but I'm going to ignore you.
Exactly.
Thank you for being honest. Anybody else? You know what's common is to do negative sine of x and then take the derivative of x and just say, oh yeah, it's just 1. Right? Now, if there were addition between those two, you would have 1 minus sine of x, wouldn't you? Okay. So a couple things we're addressing here. Why is this not the constant multiple rule? X could just go along for the right. Come on, obvious answer. X is a variable, right? X is not a constant. So we have dy dx, which is negative x sine of x plus cosine of x. All right, that is our derivative with just the negative multiplied out front. All right, so 2 things you need to write the equation of a tangent line. A point and a slope. The point is 1 comma 1 times cosine 1. What's cosine of 1? Did you say 0.54?
Yeah.
Let's go 3 decimals always. So who has it to 3?
0.5.
Okay, so I guess there would be acceptable to say 0.54. All right, but I'm just going to be honest with you right now. From here on out, if you don't have it to 3 decimals, I'm going to have to count off because they will count off on the AP test if it's not the 3 decimals, either rounded or truncated. So there's our point. How do we get the slope of the tangent line? Plug 1 into the derivative. So help me out with that. Negative 1 times sine of 1 plus cosine of 1. Make sure you're in radian mode. Everybody practice, everybody type this in, practice doing it. Come on.
I got negative 0.301.
That looks right to me. It's been a year since I've done this one, but I think I remember it being a weird decimal less than 1. Less than, well, between negative 1 and 1. When you see that slope, what are you thinking about the graph at this point? because we've been connecting position and velocity, and not that this problem was a position and velocity and acceleration question, but if your position function is x cosine of x and the derivative is negative 0.301, what information does that tell you about the original, Emma?
The curve is going towards 0. And then like negative.
So it's negative, so the slope is negative, which means the function must be going down at that point. And 0.301, I don't know if it's going towards 0, but at least it's close to 0, right? It's a slope that's negative but close to 0. So at that point, the function is relatively flat, at that point. Not, maybe flat is a bad explanation. It is close, the slope is close to horizontal, okay, at that point. All right, so our equation of our tangent line, y minus 0.54 equals negative 0.301 times x minus 1. Normal line, y minus 0.54 equals, what's the slope of the normal line? What'd you get?
1/.3.
Yeah, good, you made it positive, good. And the reciprocal, right, 1/.301, which is? Gotta be more than 3, right?
3.32.
Thank you. 3.322. Just kind of a eyeball test. This is close to 1/3, so the reciprocal should be close to 3. Okay. There you go. Questions on that one? Now we're combining a product rule and trig, so be careful with this. Matthew?
How'd you get the slope of the normal line?
Yeah, so it's the opposite reciprocal. They're perpendicular. So I did opposite reciprocal. That's supposed to be a 0. So the reciprocal is, if you put 1 over, like, for example, if I say 2/3 is your tangent slope, 2/3. The opposite reciprocal 2/3 is negative 3/2. Well, 1 over a fraction will flip it, will automatically flip it, right? So if I put 1 over a decimal, it'll do the same thing, it'll flip it. So when I get it in the calculator, I did negative opposite, and I divided 1 over that to make it the reciprocal. Very good? Okay. Homework questions, how did it go? And you'd like to have the answers to or see worked out? And
7 and 9.
7 and 9. 7 was y equals, was that the 4 over cosine of x1?
Yeah.
All right, did you, okay. Do you remember hopefully my rule for when to avoid the quotient rules for polynomials did not trip you up for trig functions? Remember with polynomials, if it was 4 over x cubed, we could bring it up as x to the negative 3 and use the negative power rule, right? Nobody tried to bring this up, did they? Did you? If you brought it up, what did you bring it up as? Anyone? Come on, own it. What did you try? Be honest.
4 cosine, but x to the negative 3.
Okay. 4 cosine x, like this.
Yeah.
That is correct. That is accurate. However, it's not going to be until section 3.6 that we know what to do with an expression raised to an exponent. Okay, we know what to do if it's 4x to the negative 1. That's not an expression raised to an exponent. That's a variable raised to an exponent. We have that. This is composite. This has a function, an expression inside of a power. Do you see the difference? Same thing as 4 times 3x minus 2 to the negative 1. That's not a variable raised to the negative 1. That's an expression raised to a power. We don't know what to do with that yet. So you're not wrong. It's just we don't know what to do with it yet. And once we do know what to do with it in section 3.6, some of you may choose to do it that way. That's fine. Okay, that's fine. But we're not quite ready for that yet. There is one correct way to avoid the quotient rule on this one. Does anyone know it? I'm going to do this with the quotient rule, by the way. Equivalent or not equivalent? Equivalent, right? Equivalent or not equivalent? Equivalent. Have I done any calculus yet? No, I've used identities to rewrite the problem. I have not done any derivatives yet. What's the derivative of 4 secant x? Well, what's the derivative of secant x? Because the constant's just going to go along for the ride. Derivative of secant x is secant x times tangent of x. So the answer is going to be 4 secant x tangent x. Now, there's not 2 multiples of 4. There's only 1 multiple of 4 that goes along for the ride, and the derivative of secant x is secant x times tangent x. Does that make sense? Okay. Now, that's not the way we're going to do it this time, because I bet most people did the quotient rule. Ready, love? What's d high? 0. Minus high? What's d low? Over cosine squared x, same as cosine of x quantity squared. If you're typing it in the calculator, you're going to want to put in cosine of x parentheses quantity squared. Our calculator does not recognize cosine squared x. All right, first term goes away. We get positive 4 sine of x over cosine squared x. How many of you got that and stopped there? Okay, how many of you kept going? All right, so if you kept going, you have, ready, 4 sine of x. This is technically, the denominator is technically cosine of x times cosine of x. Okay, the only reason I'm doing this, I'm not breaking my rule earlier where I said don't expand the denominator. Technically, that's like when you have a polynomial, you're foiling it out. I don't want you to do that, okay? But this might be helpful to, there's a factor of 1. It might be helpful to recognize some identities here. So I have a 4. A sine of x over a cosine of x is a tangent of x in the top or bottom? Top, right? And a 1 over cosine of x is a secant of x. Isn't math beautiful? Come on, that's kind of neat how it worked out both ways. The identities. Now, if you got this on a quiz, I would accept that. All right, I might not. I'd have to give you pretty clear directions as to how far to simplify on a problem like that. We good? Andrew?
If you did say that you wanted it in that 4 tangent x times secant x, but you say that we have to rationalize the denominator.
No, that wouldn't be rationalizing, because the rationalizing would be like if there's a square root down there. This would be, honestly, I don't even know a case where I would say how to simplify that. I would give you guys the options. Because the AP graders are pretty lenient when it comes to that. I will tell you this, on the next quiz coming up, there will be a case where I say simplify completely. And what I mean is, do you remember the problems yesterday that we did where there was actually an identity in the numerator that reduced? That's where I'm looking for. If there's an identity that reduces, like a sine squared x plus a cosine squared x. You have to just recognize that's 1. All right, after 7, next question from the homework. 9. Like cotangent x over 1 plus cotangent x. By the way, it would be illegal to try to divide these. Okay? If you're ever not sure about that, make yourself up a little simple problem, like maybe 3 over 3 plus 9. Okay? What do you know is the correct answer here? 3 over 12, which reduces to 1/4, right? That's the correct answer. And then if you think you may try to do some weird fraction rules, try it on here. Like maybe you're thinking, let me try this. Is that going to work? What would that be? 1 plus a third? No, what even would that be, right? So if you tried some weird algebra stuff on it, try it with some simple numbers that you know the result to and see if that property works. No, and that's not the perfect mathematical answer. I mean, it might work for one case and not for every case, but it's at least a good way to test if you forget an algebra rule. All right, so I'm not going to try anything weird. I'm just going to go ahead and do which rule? Quotient rule. Low. What's the derivative of cotangent of x? Good. So low, d high, minus high, d low. Well, the derivative of the denominator, the derivative of the first term is 0. The derivative of this, plus the derivative of the second term, it's another negative cosecant squared x all over 1 plus cotangent x quantity squared. And I know I'm not trying to insult your intelligence, but is a power able to be distributed to both terms in the denominator? Can I say this is 1 squared plus cotangent squared x? No. That you have to FOIL, right? You'd have to FOIL it. I don't want you doing that right now. All right. So let's see if the numerator simplifies. If I distribute this, I get negative cosecant squared x minus cosecant squared x cotangent x plus, now I wrote the cosecant term first. I'm going to write it first over here as well. Cosecant squared x cotangent x all over 1 plus cotangent x quantity squared. Anything able to cancel? Yeah. I have a negative cosecant squared x cotangent x and a positive cosecant squared x cotangent x. Those cancel. And I am left with negative cosecant squared x over 1 plus cotangent x quantity squared. Is that how they left it? Yeah, they wrote another identity. Sometimes the book will try to reduce or simplify, whatever they want to call it, into a different form. If you're not sure if it's the same as what you got, a good way to do it, to test it, is just to graph both. Graph what you got, graph what they got, and see if it's the same result. So I would write this one as negative cosecant squared x over 1 plus cotangent x quantity squared. Other homework questions? Put Marissa in the head.
On a couple of them, it said like describe the motion of what's happening.
Mhm.
Are we gonna have to do that on the quiz or whatever?
Not with like harmonic motion where there's like, you know, in trig we call it periods, like periods of, you know, intervals that keep repeating. Be able to describe the motion, but maybe with something polynomial, like we did yesterday, like the velocity graph was linear. Oh, so the particle was moving to the left up until, I think yesterday our problem was 1.5 seconds, 3.5. And then it stopped, changed direction, and moved to the right from 1.5 until be able to do that. You good on that?
Yeah.
Evan?
Mine was kind of similar to hers, but I was just wondering, are we allowed to use our calculator on these, like, for 13? Like, you don't have to.
You'd have to on 13, yeah. Since it had that 3 in there. If it was like just sine of t, like for example, if it was just sine of t and that's the position, what would the velocity be? Cosine t, right? So then, okay, starting at 0, cosine of t at 0 is 1, right? So your velocity at 0 is 1. So it starts off, the object starts off moving to the, well, velocity is positive, moving to the right. And then when does cosine of t hit 0? Well, cosine of 0 is 1. Cosine of pi over 2 is 0. Okay, so on that interval from 0 to pi over 2, now this is one I just made up. From 0 to pi over 2, the particle moves to the right. Or if it's a weight bobbing up and down, it's moving up, right? Pi over 2, cosine pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2, 0. Okay, so on that interval, cosine was negative, right? So the object was moving either down or left. So that's the kind of problem you have to be able to do without a calculator. Since they threw that 3 in there, you have 3 cosine t, and yeah, I guess you could do that without. But I thought at first I was thinking 3 plus, but 3 radians is like okay, not really sure exactly what that is. Others. All right, let's finish off this lesson. So we're going to need to know the trig derivative rules. There was the problem that we did to start class. Had a very small negative slope. Okay. There's the tangent line. All right. I guess that was the last problem. I thought there was another one. That was it. So it's time for our Kahoot.